If I ask you to find the similarities between these pictures, what will you say? Yes, all three are electrical appliances which we use in our daily life. Anything else? Okay, there may be one similarity which you missed out. Can you guess? All the appliances have something which spins or rotates. The blades of the fan rotate and give us air. The blades of the grinder rotate to grind something. And the part inside the washing machine rotates to clean the clothes, right? But what exactly helps the appliances rotate and do their work efficiently? Let's have a closer look at these appliances and find out. It's an electric motor. Yes, the electric motor helps in the rotation. But what does an electric motor do? The electric motor is a device which converts electric energy into mechanical energy. It's as simple as that. Electrical to mechanical. But how is it doing all this? To make it easy to analyze, let's break it down to the simplest form. Now this diagram makes it a little easier to understand. It consists of a rectangular coil made up of insulated copper wire. To understand the concept better, let's name the points as A, B, C and D. This coil is placed between the two poles of a magnetic field and it is perpendicular to the direction of the magnetic field. Here the magnetic field will be from the left to the right and the plane of the coil will be perpendicular to it. What are the ends of this coil connected to? They are connected to the two halves of the split ring. Let's call the two halves P and Q. Do you see an axle here? Yes, the inner sides of the split ring are insulated and attached to the axle. What about the external sides? The external sides conduct electricity and touch two stationary brushes X and Y. And there's a circuit here with a battery and a plug key. Now when the plug key is closed, how will the current flow? It will go through this brush X, then through this coil and from Y back to the source. Now if we look at side AB, we see that the current is flowing from A to B. And on the side CD, it's flowing from side C to D. And as we know, the magnetic field is in the direction from the left to the right. Can you find the direction of the force applied on side AB using the Fleming's left-hand rule? If we hold the three fingers like this, we see that the thumb is pointing in the downward direction. It means a downward force is applied on side AB. What about the direction of the force on side CD? Remember, the direction of the current is this way. Yes, an upward force. Because of these two forces, the coil and the axle rotate anti-clockwise. But notice what happens after half a rotation? The current in the coil gets reversed. If you remember, it was from C to D. Now it's from D to C and from B to A. So now applying the Fleming's left-hand rule again, arm AB is now pushed up and arm CD is pushed down. That's what leads to continuous rotation. The reversal of current is repeated at each half of the rotation. Do you know what a commutator is? It is a device that reverses the flow of current in a circuit. So can you tell me what acts as a commutator in this mechanism? Yes, it's the split ring. It reverses the flow of current. So this is how an electric motor works. In the next lesson, we will cover a very important topic called the electromagnetic induction.